Okay, for section 4.4, we are continuing with the elimination process, but in this case, sometimes the variables will not cancel and you will need to multiply one or both equations by something to make the variables cancel. So if I look at number 1, they do line up, the x's line up, the y's line up, the equals and the constants line up, but the x's don't cancel and the y's don't cancel, so I need to multiply by something to make them cancel. Okay, because I see this x does not have a coefficient, I'm going to try to match up that coefficient. Okay, I can see that up here I have a positive 3x. So if this were to cancel, I would want this to have a minus 3x in front of it. Okay, so the way I'm going to make it have a minus 3x is I'm going to multiply the entire equation by negative 3 to make sure that there is a negative 3x in front. So the first equation I did nothing different to. For the second equation, I'm going to multiply the entire thing by minus 3x. So now I have negative 3x, negative 3 times minus 2y makes it positive 6y. Negative 3 times 1 is minus 3. You know, if I've done this correctly, something should now cancel. Okay, if I look at this, 3x minus 3x, that cancels. 5y plus 6y is 11y. 25 minus 3 is 22. And now I can continue solving using the elimination like we did on the previous day. So I do get y is 2. I'm going to plug the y is 2 back into one of the equations. You could plug it into this equation, or your new equation that you multiplied by. They all give you the same answer. I'm going to go ahead and plug it in the 3x plus 5 times y equals 25 equation. I got y equals 2. And I only picked that because it had all positives, and some of you don't seem to prefer positives. Okay, 3x plus 10 equals 25, so now I can solve it like a two-step equation. So x equals 5, and then remember to write your final answer as an ordered pair. The x goes first, the y goes second. So 5, 2 is my final answer. And if your work is different, but you showed your steps and you got the same answer, then you're fine. Okay, I'm going to go ahead and look at number 2. For number 2, it says 3x plus 2y equals negative 5, and 4x minus y equals 8. I'm going to check if they're lined up, and then I'm going to check and see if anything's going to cancel. Okay, the x's are lined up, the y's, the equal, and the constant. The x's do not cancel, and the y's do not cancel, so I'm going to try to make them cancel. There is always more than one way to do this, but if I see a variable that has no coefficient, I normally try to work with that one. So I can see this y down here, it's a minus y, but it doesn't have a number in front of it. Okay, so let me compare it with the other y. This is a plus 2y. So if this was a minus 2y, it would cancel. It does have a minus, but it doesn't have a 2. So I'm going to multiply that whole equation by 2 so I can get a minus 2y in front of the y. Okay, so the first equation I didn't do anything to. On the second equation I multiplied by 2. So 2 times 4x is 8x. 2 times minus y is minus 2y. 2 times 8 is 16. If I have done this correctly, I should be able to cancel something now. Okay, let's see. 3x and 8x is 11x. 2y minus 2y cancels. Negative 5 plus 16 is going to be 11. Okay, that's perfect. Now I can solve for x. I get x equals 1. I'm going to plug the 1 back into one of the equations, probably one of these. I could plug it in this one or this one. I'm going to go ahead and use the first one. 3 times x, what's x? 1, plus 2y equals negative 5. I'm going to multiply this out, and it's going to turn into a magical two-step equation. Okay, that's a positive 3, so minus 3 minus 8, divide by 2. Y is negative 4. And I do write it as an ordered pair. The x goes first, the y goes second. Let's go ahead and keep trying these ones. It's the first step that is a tricky one. Okay, so for number 3, it says 5x minus 6y equals 4. 4x plus 3y equals 11. Okay, they are lined up, the x's, the y's, the equal, and the constants, but this doesn't cancel and this doesn't cancel, so I want to try to make them cancel. Everything, there's no blank coefficients, or I would try to fill in the blank. So let me think. Do I want to try to turn a 4 into a 5? No. Do I want to try to turn a 3 into a 6? I could do that. I could times by 2. Okay, let me look at this. If I times it by 2, what would I get? 2 times 3y would give me positive 6y, and this is a minus 6y. Okay, so timesing by the second equation by 2 would work. Okay, there's other ways to do it that would also work. So if you're doing it differently, try it, and then see if we get the same answer. 2 times 4x is 8x, 2 times 3 is 6, 2 times 11 is 22, and make sure you remember to multiply the last number too. Okay, let's see. 5x plus 8x is 13x. Negative 6y and positive 6y cancel, which means I did this correctly. 4 plus 22 is 26. Okay, divide by 13. I get x is 2. Okay, now I can plug it in any of these equations, this one, or the red one. I'm going to use the 4x plus 3y equals 11. And again, I only do that because some of you don't prefer negatives. If you don't mind negatives, you might want to plug it in the first one or the red one. 4x plus 3y equals 11. Okay, 4 times 2 is 8. And I multiply it out so that I can solve it. Okay, now I'm going to solve this. It's a two-step equation. Minus the 8. I get y is 1, and then I'm going to write my answer as an ordered pair. The x is first, the y is second. So 2, 1. Okay, we're going to do 3 more, and this time we're going to have to multiply both equations, which occasionally happens. Okay, let me look at number 4. Number 4 is lined up. I see the x's are lined up, the y's are lined up, and the constants are lined up. But the x's and the y's, neither of them cancel. Okay, now 2, there's nothing I can times 2 by to get 3 easily. There's nothing I can times 3 by to get 5. Okay, so I'm going to have to figure out how to do both, multiply both equations by something. There's more than one way to do this. I think I'm going to cancel out the x's. Okay, let me just look at this for a second. Okay, I have a 2x here and a 3x here. I'm going to have to turn them into a bigger number, but I'm going to have to turn them into the same bigger number by multiplying. Okay, so I know I can turn them both into 6's. Okay, or in your head you can say 3 times 2 is 6. I'm going to turn them both into 6's. Okay, so let me think. If I want the first number to turn into a 6, I have to times by 3. If I want the second one to turn into a 6, I have to times by 2. But then I'm going to pause because this is not quite right. If I do 3 times 2, I get 6x. 2 times 3, I get 6x, which is great, but I need one of them to have a negative so that they will cancel. So for one of them, it doesn't matter which, I'll put a negative in the front. Okay, I'm going to multiply this out, and then we're going to see if it works. If it cancels, we did it right. So for the top equation, 3 times 2x is 6x, 3 times 3 is 9y, 3 times 2 is 6. On the second equation, I'm multiplying everything by negative 2, so negative 6x. Negative 2 times minus 5 makes it plus 10y. Negative 2 times 22 is negative 44. Okay, now if I did this right, something should cancel. Okay, 6x minus 6x cancels. Wonderful. 9 plus 10 is 19y. Negative 6 minus 44 is going to be negative 38. Okay, and even though these numbers look a little big, once I solve it, they normally turn out pretty nicely because I try not to give you terrible numbers. Okay, 38 divided by 9 is actually 2, so y equals negative 2. Okay, now when I plug it back in, I could plug it in the 2 original equations, or I could plug it in the ones after I multiplied. I like to plug it in the original ones just because the purple ones have bigger numbers. That's the only reason. So 2x plus 3y equals 2. So 2x minus 6 equals 2. I'm going to go ahead and solve this. I get x equals 4. So x is 4, y is negative 2. Okay, and if you used a different equation, we would still get the same result because it's the same system of equations. Okay, This is tough. We're going to do 2 more. Okay, let's try number 5. Number 5, negative 2x plus 7y equals 6. 5x minus 3y equals 14. Okay, let's see. The x's are lined up, the y's are lined up, but they don't cancel, which is not good. If I could times 2 by something to get 5, it would be great. If I could times 3 by something to get 7, it would be great, but those don't come out nicely either. So I'm going to have to use both equations. Now, whether you want to cancel the x's or y's is up to you. I normally pick the ones that have smaller numbers, just because it keeps the numbers smaller. So between 2 and 5 and 3 and 7, I'm going to work with the 2 and the 5. Again, that's only because they're smaller. Okay, I want to turn them into a bigger number by multiplying. Okay, if you think of the least common multiple, it's 10. Or if you have no idea what a least common multiple is, if you just do 2 times 5, you get 10. So I'm going to try to turn them both into 10s. Okay, for the top equation, it's a negative 2x. So if I want it to turn into 10, I'm going to times it by 5. Okay, for the second equation, if I want the 5x to turn into a 10, I times by 2. And then I'm going to pause and check my signs. Okay, 5 times negative 2x is negative 10x. 2 times 5x is positive 10x. Okay, so this is actually good just the way it is, because I want one to be positive and one to be negative for them to cancel. So I'm going to go ahead and multiply the top equation by 5. And I'll multiply the second equation by 2. And make sure you multiply all of the terms. Okay, now if I've done this right, something should cancel. In this case, the x's cancel, which is what I thought because I made them match. 35y minus 6y is 29y. 30 plus 28 is 58. So I get y equals 2. Even though there's big numbers, they should come out to be nice numbers. Use your calculator. Okay, and then I can plug it in any of the 4 equations I started with. Which one should I use? I think I'm going to use the 5x one. So 5x minus 3 times y equals 14. Okay, and I didn't have to use that one. I could have used the negative 2x plus 7y equals 6 or one of the pink ones. I just glance at it and think, does that look easier or harder than the other ones? So I got x is 4, y is 2. So 4 comma 2 as my ordered pair. And if you did it differently, we should still get the same answer. Okay, last one's number 6. Okay, let me look at this. Lined up x's, lined up y's equals numbers. That's great, but nothing cancels. If there's an easy way I could multiply 2 by something to get 3, that would be great. 4 times something to get 5, there's nothing. Okay, so again, you can cancel the x's or y's. It does not matter which one you cancel first. I just look at them and if one of them looks easier to me or if one of them has smaller numbers. So in this case, I'm going to do the x's just because 2x and 3x are a little smaller. Okay, now I want to turn them into another number by multiplying. It's going to be a bigger number. Some people think least common multiple, and they know that the least common multiple between 2 and 3 is 6. If you have no idea, I do 2 times 3, I get 6. Okay, now I have to think. If I want the top one to turn into 6x, I have to multiply it by 3, because 3 times 2x will give me 6x. If I want the bottom one to equal 6x, I have to do 2 times 3x. Okay, and then I'm going to check my signs before I proceed. 3 times 2x is 6x, 2 times 3x is 6x, which is wonderful, except I need one of them to be negative, and right now they're both positive. So either one, give it a negative. Doesn't matter which one. Okay, I'm going to go ahead and distribute. Okay, and then again, if I've done it correctly, something should cancel. So 6x minus 6x cancels. 15y minus 8y, 7y. 0 minus 14 is negative 14. So I'm going to get y equals negative 2. Okay, and then I can plug the y equals negative 2 into any of the equations I started with x and y. I'm going to put it in the first one. 2x plus 5y equals 0. So 2x minus 10 equals 0. then make sure you write your answer as an ordered pair. 5, -2 is my final answer.